All right. Good morning. Thanks, everyone, for joining the Spring XD webinar. Let's start the session to see how Spring XD can help with big data application development and at the same time improve developer productivity. But before we begin, let's quick introduction about the presenters. Mark Fisher.
Hi, I'm Mark Fisher. I'm a Spring XD co-lead and formerly the lead and founder of the Spring Integration Project, which is one of the foundational projects for Spring XD itself.
Mark Pollack.
Family of projects as well as Spring.net.
And myself, Sabby Anandan, and product manager for Spring XD. So what we have in the agenda today is a quick walk through on the basics of Spring XD and the architecture and all the components that go together with Spring XD's runtime. And we have some exciting new features added as part of our functional stream processing integration with Project Reactor and RxJava and Spark Streaming. We'll be walking through some of the examples and demonstrating the process as well. We also have new integration endpoints with Spark Streaming, and also rich integration with Spark at the batch job. We'll also be demonstrating that. And towards the end, we'll talk about how Kafka plays an important role in Spring XD's runtime, used as a message bus and also as a source and a sink. And how we actually use Kafka at the message bus level. How do we actually data partition? So we'll be demonstrating some of the capabilities there as well. So before we actually talk about the architecture, I want to really run down on the actual value proposition of Spring XD. So people who are familiar with Spring Integration and Spring Batch as standalone projects, it's a typical jar file you pull in and then you write your code and then deploy your application. Whereas in Spring XD, so it's built at its foundation using Spring Integration and Spring Batch, along with several other Spring projects. So unlike other Spring frameworks or other projects, Spring XD is a runtime. So it unifies, the stream and then the batch workload, so you can build more comprehensive data pipeline workflows. And at the same time, while using Spring XD as a runtime, so you can individually evolve streams and jobs, the applications in Spring XD in isolation. So what I mean by that is you can have several streams, several batch jobs running in the cluster. So the application that is your stream or the job that you're developing, so you can independently evolve that without disrupting other data pipelines that is running in the cluster. And Spring XD runtime comes with an out-of-the-box non-functional requirements. So it's fault tolerance, high availability. So we try and manage all that. We abstract that away from the developers. So you focus only on the business logic. So you define your applications in Spring XD, and the remaining orchestration and infrastructure specifics will be taken care of by Spring XD runtime. And Spring XD runtime is extensible. So at any given point, you want to have some proprietary source, proprietary data format that you want to consume, and you want to do some interesting thing on that data. So we expose all the abstractions, so you have a way to implement the abstraction and then do your own business logic, override specifics, and you build your custom data pipeline, and we make that seamless and straightforward as much as possible. And the runtime is portable, so it runs with JVM. So what I mean by that is you can run on EC2, you can run on Mesos, or you can have it run on Eon, or even as a Docker container. And we also have Spring XD running on Pivotal Cloud Foundry. And the last part that I have is, writing data to Hadoop. You don't have to worry about integration headaches or, trying to manage all this mapping and how do we actually write and where do I point to the name node. So we try and make that seamless and straightforward. So that it's developers get out of the box tools, just not worry about all the infrastructure again. You just worry about your business logic and building the data pipeline. So we talked about some of the components. So the distributed runtime, Spring XD, in this visual from top to bottom, as you can see, the social data or internet data or files, structured or unstructured data. So we expose a wide variety of Spring integration adapters. It's part of our runtime. So you just point to the specific adapter and create your data pipeline using that specific source module. And Spring XD consumes all that data in a uniform manner. And below that, you have streams and jobs. So streams is the continuous data. You want a data to be ingested in a real time, in a continuous manner. So you have streams as a developer fixture that you use via our high-level configuration DSO, which is the left top corner. So that's the shell you use to interact with our runtime. And you use stream APIs, stream fixtures to create those data pipelines. Similarly, you'll also create, like a batch job. A batch job, in a sense, is a sequence of steps. It's a directed acyclic graph. So you have a scenario like you want to ingest data, consume it, transform it, and land it somewhere. If the data is written somewhere successfully, then you notify, or if it's failed, again, alert or notify. So such workflows, a sequence of operations can be orchestrated using a batch job. And the stream can trigger a batch job and batch can trigger a stream, so it's bidirectional. So it gives you more flexibility to build more comprehensive data-centric use cases. And both the streams and jobs, allows you to write the data to vary the destination. So in this diagram, you can see we write it to the compute layer, that being a master data set, like Hadoop. And once data is there, you have, again, you out of the box, we provide fixtures to export that data to a database or NoSQL store, or even tools like R or SAS, even MATLAB. So you can do offline analytics. You can do, machine learning, data mining algorithms that you can, in its native format that tool gives. And you do all that in that tool and get that model in PMML specification and give that back to Spring XD and use Spring XD's tab that you see on the left side. So as the data is consumed in real time, you use tab to fork that data and then apply this model on top of that data. And the real-time predictions are computed, and you have that staged in an in-memory store like Redis, for example, in this visual. And the dashboard can feed on it. So all these different peripherals or different programming model and the developer-friendly fixtures are all exposed out of the box in Spring XD. Let's quickly see how these components come together. So I have in this terminal, I'm highlighting Redis. So Redis is used as an analytics store by default. Again, this is pluggable. You can change to any other in-memory store. So this is used for staging the metrics. So we have our REST APIs that can give you access to those metrics to feed your dashboard. And Zookeeper plays an important role, so that helps in coordination between admin and container nodes. And Rabbit and Q, I have it started. So this is a message bus that is used in our runtime that helps transmitting data from module to module. I'll demonstrate on the screen. I'll explain how Rabbit plays an important role there. And I haven't started Kafka yet, but we'll cover that shortly. And I have a database running, HSQL database. So this is necessary for a batch job because the job repository or the batch definitions are persisted and also execution listener details are all persisted as well. So you have a historical snapshot of all the batch jobs running. And I have xd-admin. So this is the gateway for you actually interact with, whether using DSL shell or the admin UI, which I'll show momentarily. And this server is responsible for receiving your request. A request can be creating a stream application or a job application, and it deploys that stream definition in the containers. These are the containers that I have. I have 2 containers started locally. So admin actually deploys those containers, and then it updates the runtime state saying, hey, it's updated. In containers that I'm highlighting, XDC1 and XDC2, these are the 2 containers I'm running. This is where actual processing units are actually deployed. And the modules deployed here communicate, via the message bus. And finally, this is the shell. So if I do module list, so this is the client endpoint that interacts with the admin server. So I did module list, and these are all the out-of-the-box adapters that I was referring to. So out of the box, you have the first column, all the source adapters. So these are all the Spring integration adapters that you can use in Spring XD to consume data from all these varied sources. Once the data is in pipeline, you can use any of the processor modules to, cleanse it or filter it, transform it to desired format. And data is formatted, or, you have data in that desired format. You can write it to any of our sinks. And we have out of the box all these sinks available. There's NoSQL stores, SQL stores, And the last column is all the out-of-the-box batch jobs. Like if you want to use the data from HDFS to JDBC, you can use that job, or the reverse, like consume data from database all the way to Hadoop. So this, in general, how we actually create an application using the shell. We also have the admin UI. I'm quickly going to open that. So I go to the containers tab. I have 2 containers running. This represents that, and you can kill the container, manage it from here in the UI as well. And the streams tab, you can actually see all the streams running in a table, and you will also demonstrate that once you have some streams deployed. Same with the jobs. The one added feature that we have in jobs is you have all this jobs as a template. So you can basically use this to create a job, filling all the necessary parameters, and you can deploy that job directly from the UI. So again, this goes back to our developer-friendly fixtures. So you have the shell that is gives you all robust fixtures for you to create these screens and deploy these jobs. So quickly going to the next slide. So we talked about Hadoop, without integration in it. So what I mean by that is this visual. So if you want to get up and running using Spring XD, if you want to write your data using Spring XD to Hadoop, all you have to do is just go point to our yum repo and do yum install Spring XD, or use the brew coordinates and say brew install Spring XD, or just download the bits and go to that folder and spin up a single node, which is the second white rectangle that I see there, that I'm showing there, and also open the shell. And then comes, you have option, whether it's shell or the UI, you can interact with the runtime to create a stream. The last black rectangle actually shows the stream definition to write data into Hadoop. So this is all you need. So you don't have to worry about specific integration code or any glue specific code to write to Hadoop. You just have all these fixtures available out of the box. Let me quickly demonstrate how we write to Hadoop, the same example that we saw in the deck. So I have Hadoop running locally. In fact, all the components that I was walking through, everything is running locally in my machine, my laptop. So I have Hadoop already running. So all I have to do is I have to point to the name node in the shell. So I'm saying Hadoop config, and the file system, the name node is at that location. And then I go back and I create a stream. So I'm saying stream create. The name of the stream is HTTP-HDFS. And the definition for that stream is, hey, go consume all the data that I'm going to receive from HTTP. The default port is 9000. That's configurable. So once the data is in the pipeline, I want to, so the pipe that represents the message bus here. So HTTP is the source module, and HDFS is the sync module. They both are connected via the bus, so that's why they are loosely coupled, so you can independently evolve that as well. So in this definition, I'm going to consume all this data from HTTP, and I'm going to write it to Hadoop. So I just deploy that stream. And while this is deploying, I also want to make sure, I want to demonstrate one other feature while the data is consumed. I want to create another stream. I'm going to tap that stream. The definition for the stream is tap the stream named HTTP-HDFS, which is the previous stream. And while the data is being written to HDFS, I want to also tap that data and give it to a counter. The counter is nothing but out-of-the-box sync module that we have. It's just going to count how many times the data is written. So just to demonstrate how you write to Hadoop and at the same time also do some simple metrics out of the box in Spring XD. So I have 2 streams deployed and list the streams, and I see the stream and stream definition. I go back to the UI. I go to the containers tab, and those streams are deployed here. Spring XD automatically distributes the load between the containers. So these modules are automatically distributed at its best effort between the containers, and that's why you see them listed in both the containers. So now that I have the streams, so let's post some data. I'm going to do a simple curl. I'm going to do 5 times the test message with the index Spring data on it. And I'm pointing to localhost 9000 because this is the port that my stream is listening to. I posted the data, and I go back to my shell. I just want to list the Hadoop folder to see the files being written. So I see a temp file actually written. Before I want to explain why the name of the folder is HTTP/HDFS. So I can configure while deploying the stream which folder I want to write to, but if it's not given, the default is it goes by the stream name, and XD is the namespace, default namespace. It starts with that namespace, and then it creates a folder and then creates a file with that same stream name. But notice that you have temp attached to the file name. That's the reason because the stream is a continuous thing, and by default, the file is set to 1 gig rollover. So it's going to consume data until 1 gigabyte, and then it's going to close that file and open another file. So it's buffering at this point. So what I'm going to do is I'm going to undeploy that stream, destroy. So that way the file is written, the file is closed, and I can actually view the content. So now the file is written, and I'm just going to do a cat on that specific file, and there it is. So this gets back to our point, right? I mean, we are giving you these fixtures and use your developer experience for you to write to Hadoop. You don't have to, really go low level and then configure things and be able to do all by yourself. We're trying to make that seamless and straightforward. Now that we confirm that the data is written to this file, let's also see what the counters are. So I also was doing a counter, like I had a stream that was counting how many times the data is being written. So now that the counter stream is deployed, I'm just going to display that, and I see there are 5 entries in that. If I post more data, let me quickly deploy the stream again. So if I go back to this curl and post more data and go back to my shell and display the counter again, I see 15. So I posted it 3 times. So this again demonstrate out of the box you have easy fixtures to write to Hadoop and as well as be able to do some simple metrics in computation. Okay, moving on. Let's see. The next thing what I want to cover is the functional stream processing and the integration endpoint that we provide out of the box. So to learn more about our integration with project Reactor and RxJava, I'd request Mark Pollack to walk us through this slide.
Yeah, hello everyone. I wanted to talk about stream processing, functional stream processing capabilities that are available in XD. There are 2 libraries that let you do stream processing inside the single JVM. These are Reactor and also RxJava. They're fairly similar in terms of their architectural style, but their APIs are somewhat different. Nevertheless, they both expose APIs that allow you to apply functional concepts such as map and reduce, flat map, etc., to data that is being ingested. This also includes time windowing capabilities, such as every 10 seconds, perform a calculation on the data, or event count windows, or whichever comes first, 10 events or 10 seconds, things of that nature. So the work that we've done here is to make it very simple for you to hook up this functional processing code into the event stream. So what we do is provide the infrastructure that glues together the messages that come off the message bus, and then sends them to one or more of these stream instances. So if you tab down, one moment there. So there is a stream API that you need to implement, and it's as simple as a process method that has an input stream, and then you return an output stream. And this is where you put your functional programming code, and it's very easy to unit test, and we provide facilities for performing an integration test inside of a single node server. And what you can do is you can have multiple stream instances based off of the data coming on the message bus. So for example, this allows you to calculate state in a specific stream that's unique to some data that is present in the incoming message. So for example, if you wanted to do time window calculations for a specific customer, using a Spring expression language, you can say, create me a stream that's unique for each customer ID. Then you'll have the state of that calculation calculates specifically for that that customer. Similarly, if you're using, let's say, the Kafka message bus, Kafka already has a partitioning scheme built into it directly, so you could have a stream instance per Kafka partition using this Spring Expression Language functionality in the Reactor processor. So it's a quite powerful way to implement functional APIs, and in particular, if you complement this with the capabilities we have on the message bus to partition data, namely if you had multiple JVMs running multiple instances of this Reactor processor, we can siphon off different subsets of the data to specific JVMs consistently. So, for example, all the gold customers and all the silver and bronze customers going to 3 unique JVMs. So there's quite a lot of flexibility here for you to map out your own functional APIs across a distributed cluster. If you page down one more to the RxJava observable API, it's very similar in terms of how we interface with the functional APIs available in RxJava. This time it's through the observable interface, which is the key interface in RxJava. And there you have access to all the unique native capabilities of RxJava. But otherwise, fairly similar in terms of the general look and feel and how you integrate this processing module into XD. The output stream then is sent to the message bus, which then continues down processing to either other processors, which might be interesting as well, or to another sink. So I'll hand it back to you, Sabby.
All right, great. Thanks, Mark. So let's quickly see a demonstration on how RxJava and Reactor play well together with Spring XD. Before I do that, I want to clean slate all my streams. Let me make sure that there's no streams there. Okay, so there's no streams there. So what I'm going to do now is, so I have a simple sample project. All I have is this moving average code. So this is the process that Mark was referring to. So we implement that. And the process method, when you override it, so this is where your actual business logic will be. So you get that input stream, which is you consume that data that's consumed from one of our sources, and this being a processor intercepts that data. And inside where is actually you have your business logic. So what I'm going to do in this demonstration is I'm interested in calculating moving average. So I'm expecting an ingest of data of type tuple. Inside tuple, I'm interested in this key measurement. The value of that, I would want to use that and do an average once I buffer up the 5 values. So this is, again, the familiar programming model. People are used to functional programming style. You can natively use the Stream API that's offered from Project Reactor and create this example using completely with that API. And you develop this application using our startup BOM file. So we try and simplify that by making all the dependencies for Spring XD that's all abstracted and hidden behind with this artifact. And you just point the repository, and in the dependency section, whatever the dependency that is specific to your use case, you just add that and use this to start a BOM template just to evolve fairly rapidly. And you'll have your test code, and you can test that in isolation as well. And we have similarly the build coordinates, Gradle coordinates. Again, you will just add your own dependencies, and that's about it. So I have this project bundled as jar file. So what I'm going to do is I'm going to use our REST API to install this jar file. So the command for that is going back to our shell. So I'm saying module upload. The file is at this location. I have Reactor moving average, the jar file. That's in this location of my file. And the name for that is I'm giving Reactor moving average, and I'm calling it a type Spring XD type processor. And I deploy this module. I do a module list. There it is. So this REST API dramatically simplifies your custom module contribution. So you don't have to worry about bundling and worrying about bringing down the runtime. Other pipelines that are running gets disrupted. So it's immediately available for developers, right? I mean, you can immediately create a stream using this processor module. Let's see how we do that. So we did the module list. I'm going to use the stream. I'm going to create a stream named Reactor, and the definition for that stream is consume data from default port again 9000 and give it to this processor. And the processor is going to expect input type a tuple, like how we saw in our implementation code. It's expecting a tuple to be passed in, and you're going to be doing some operation walking through that object graph. And once the computation is complete and the output goes back into the bus and eventually to the sync, and we are going to log it. So I'm creating that stream, and let's make sure the stream is deployed. And the stream is deployed with that definition. And I closed it. And then I have a script file. Inside the script file, I have the data. So this data in the script file is this one. So I have like 10 records I'm posting pointing to the default HTTP port, which is 9000. I'm posting this JSON as the key measurement in it, and I'm going to use this for my computation. So I post that script, all that data is posted. Now I will go back to my log to verify it. So I see one log, which is from Reactor sync. The average is 12. So, and I see another one, and the average is 17. The reason why this split it out twice is because inside my code, we were buffering the data for 5 until 5, and then we are doing this average computation and then returning it. So that's why I posted like 10 data records. The first average was based on this, and the second average was based on this. So that's precisely how you would develop a Reactor processor and contribute to its runtime and immediately start using it. Likewise, I'll also demonstrate how we install RxJava module. Same concept, except that another jar file needs to install. So I'm going to that project real quick. It's the same structure, but except that the processor of type observable interface is implemented in this Java class. And inside the process method, you use the observable type data comes in, and then you do your computation, again, do an average, wait for 5 data, and then do an average, and return that observable tuple back to the bus. And similar POM structure and the similar Gradle coordinates on this project as well. And you have your only your dependencies added specifically. So once that is done, I have this bundle. So I'm just going to install this file as well, which is here. I go back to my shell, and I'm going to say, hey, this is where my RxJava moving average artifact is, and the type is RxJava moving average, and the type of this module is processor. I install it. As you can see at the top, the RxJava module is not listed. Now I do module list again. Boom, there it is. So it's immediately available. Again, I don't have to bring down the runtime to have this installed. Now, the similar example, I'm just going to use create another string, but this time using RxJava moving average. Other than that, the source and then the sync remains the same. I install that. And I have a similar data file in this location. I'm going to run that script. And the post is OK. I go back to my container for the logs. This time it's coming from our Java sync, and the average for the first, and then the second average for the remaining 5. So this is how Spring XD orchestrates your Reactor or RxJava code. Again, all the infrastructure and orchestration specifics are abstracted away from the developers. You worry only about your code, your business logic, and using the APIs that you're familiar with. You just right on. You just start writing your code on that, and we will handle all the orchestration specifics in the runtime itself. So that's a quick demonstration on how Reactor and RxJava plays in our runtime. Moving on. So we have rich integration with Spark and Spark streaming as well. So Spark is a distributed engine for large-scale data processing. So what is the role in Spark and Spring XD? So immediately, out of the box, all these adapters that you have, and you can consume varied sources using these adapters. You don't have to write any code for the most part, except you want to consume some proprietary data, custom proprietary data format or protocol, then you write that adapter. Again, we also provide you examples and several interfaces to implement easily to build your own solution, processors, things. Everything is customizable and extensible. So you're exposed to all these adapters out of the box. You can do interesting things once you have data in the pipeline. So once you have the data consumed and you want to delegate all this distributed computation logic to Spark, this is a Spark cluster running separately. That's where Spark is really good at all this distributed computation. And do that computation. We delegate it to Spark to do specifically that and get the feedback in the Spring XD, and you can write that data. You can save it to in-memory store so that the dashboard can be set. So we are giving that unified developer experience. Instead of choosing different tools, running different products, and maintaining them, we are making sure the runtime gives that unified, straightforward developer experience. So you can just worry about your business logic and create the data pipelines. So to quickly walk us through on Spark streaming, let's have Mark Fisher talk about the next slide.
Okay, thanks, Sabby. So with Spark streaming applications, it basically starts with the driver process, where you would typically have a main method that creates a streaming context, and that context acts as the gateway to the cluster manager, which might be local or standalone, or it could be running on Yarn or Mesos. And through that context, you establish a stream, which always begins with a receiver. And so in the Spark streaming model, a receiver will be deployed to the cluster, and it's a long-running process. It has exclusive use of one of the cores, and that receiver returns a D stream. A D stream stands for discretized stream, so it's actually a continuous flow of discrete RDDs, but those RDDs, which stands for Resilient Distributed Data Set, is the same RDD object that's used in the Spark core for batch processing. So basically what you end up with is a model where these RDDs are micro batches, and they're coming continuously. They're still partitioned. Each RDD will be batched according to the batch interval, which is 2 seconds by default. And then within each of those batches that's in an RDD, it will be partitioned and executed across, the processing will be executed across multiple worker nodes. And so that is the parallel distributed model for Spark. Basically, what we wanted to do with XD is allow you to use Spark in the way that it's intended to be used, but to take away some of the responsibilities there and make it flexible enough to plug in, as Sabby mentioned, to any of the modules that we provide. So what we do is, actually beginning with the developer experience, if you're building a Spark streaming-based module for XD, then all you have to do is implement the processor interface. And it would be a lot like what you saw with RxJava and Reactor. There's a single interface. In this case, instead of the input stream being from the RxJava API or the Reactor API, the input stream that's passed as a parameter is the actual D stream from the Spark streaming API. And then within that, you would iterate and perform operations on the RDDs as usual. So you don't have to write any code that's specific to XD at all. You just have this one interface to implement, and you're in the Spark streaming API as usual. If you return a D stream from that method, then that will be used as the output. And so by doing that, you're essentially saying that this module is to act as a processor, and you would drop it in the processor directory. If you don't want to return anything, you want to maybe use output operations that are available directly on RDDs in Spark streaming, then you would have a sync module. But either one is supported. And when you implement the processor interface, you can either implement that using the Java Spark streaming API or the Scala Spark streaming API. And then we have all of the infrastructure code to handle either one when you deploy that. So what's happening with XD when you deploy one of these modules is we're basically decorating the code from that interface that you've provided, and we're wiring it up and acting as the driver process. So on an XD container node, you have a module running like any other Spring XD module, but that module's job is to be the driver. It establishes a receiver on the streaming context, and that receiver is one that we've implemented, so you don't have to worry about that part. And the receiver is binding to the message bus and returning D streams that contain the actual messages, and then that's what you get inside the D stream, and therefore inside the RDDs where you perform your operations. So it all operates on the Spark cluster as usual, but you get the added advantage of being able to pipe either before or after using sources and sinks and other processors from XD, but also you get the lifecycle management in XD. So if something fails and goes down, then we'll be redeploying your Spark driver module onto another XD container node as normal. And you can also pass in the deployment properties like the module counts and the partition key expressions and all of those things, and those will be used at the point where we're establishing a message bus receiver for you. Everything else happens just directly off the pipe as usual. So that's about it for that. I'll hand back to Sabby for the demo.
All right, great. So let's quickly see an example of Spark streaming in Spring XD. So before I begin, I want to let you guys know that I have a Spark master running. I have 2 worker nodes running, all local. And I'm going to create a stream, which is this one-line definition. Go to my shell. So I'm saying, go create me a stream with the name Spark. And the definition for that stream is HTTP listening to the default port again, which is 9,000. And I'm going to hand it over to this word count module. So word count is another custom module similar to our Reactor and RxJava. So just for the time benefit, I already had that installed. This is another simple project. It uses a similar POM and a Gradle file to bundle that, and I had that as a jar file. And I used the module upload command similar to our Java and Reactor to install it. So it's listing there already. So the word count module is going to do, the word count using Spark APIs, Spark streaming APIs. And once the computation is complete, I'm going to hand it over to the bus, and the bus is going to log it to the log using the log sync. And let's deploy that stream. So I have a stream deployed. It's in the process of deploying, so let's make sure it's up and running. It'll try and negotiate with the cluster. So it's going to be so now that the stream is deployed, and I go back to the UI, so you can actually see that there's a Spark module running, and the streams is already actually deployed. I go back to this, and let's post some data. So I'm interested in posting this data. So it's a simple word count, so it needs to be spared out in the log file. So I'm posting it to the default localhost 9000 port. That's what the stream is listening at. So I posted that data, and I go back to one of the containers. Oops. That's not good. Okay, that's deployed. Running it as. Okay, let's try it again, see what happens. Yeah, there's some exception that's spread out in one of the containers, but the actual computation was happening in the other. As you can see, the word count did happen, and then the computation did took place in the Spark cluster, and then the outcome was handed over back to Spring XD using the bus, and the bus kind of picked it up and then handed it over to the sink, and that's the sink, which is being a log sync. It spit it out, and the results are here. So again, I'm just going to clean slate it before we proceed further. Okay, so streams are deployed. Let's go back to the deck. So the next topic that we want to cover is Spring XD in Python. So we recognize the importance Python plays in big data applications. So we want to give some rich experience for data scientists. We want to prefer Python being this programming language for writing algorithms, so that you can do some rich, leverage some rich Python libraries to do some data mining and predictive modeling things. So in Spring XD, we have Shell, which is being a processor, and we also have Shell as a sink. So what Shell is as a processor is you can issue any command. The command can be a Python command and then run a Python script. And that script can potentially have your algorithms. So in this visual that you see, the white block being the Spring XD container and we are consuming data in HTTP, for example, and the transform being an out-of-the-box transform process module, it can transforms data to some desired format, and the data is handed over to this Python file. The Python file does all this crunching, and the computation is actually given back to fed back to Spring XD runtime, and you can write that data to a file system, which probably I had to. Or while writing that we saw in the earlier demonstration, you can tap that, fork that data, and then that computation can be written to an in-memory store like Redis or Gemfire. And the rest sitting on top can, feed a dashboard. So this is a quick walkthrough on how, Python, we have out-of-the-box processor and a sink, allows you to integrate or natively call Python and do some computation. So shell and shell being a processor and shell being a sink is where we'd be integrating that. One other thing I would want to highlight here is in this visual, the white block, anything inside the white block is all automated. So you have all that exposed as user-friendly things. The things where it's highlighted as green potentially is where you actually write code. Other than that, everything right into Hadoop, tapping and right into any other data store, it's all like automated, and you just do a stream deployment and the data will be there. So it's essentially what we are trying to highlight, and the Spring XD being the unified development platform for data pipeline use cases. Okay, so moving on. The last topic that we want to cover is Kafka. So Kafka, as many of you know, is PubSub broker. In Spring XD, Kafka message bus plays a significant role in this transmitting data between modules. So that layer is pluggable. So we have RabbitMQ, and Redis is another in-memory store you can use as a message bus, or Kafka is another optional that you can use in Spring XD for creating your data pipelines. And apart from that, we also have Kafka as a source module, so you can ingest data from Kafka topics directly. Or you would prefer landing data into Kafka topics, you have Kafka as a sink. So let's quickly see how Kafka and Spring XD work together. Before I do that, so Kafka is a source module that I was pointing to. It's listed in the first column, and Kafka is a sink in the third column. So I would want to demonstrate how easy it is to swap out peripherals in Spring XD. So I killed the rabbit, I'm starting Kafka, and I'm going to restart my admin server with Kafka being the transport layer. It's as simple as setting the environment variable. We also have server.yaml file, so you can actually change that if you prefer doing that, but this is ad hoc, so I just quickly set this environment variable. I'm going to start my admin server. And the same with my containers. They are all using a Rabbit for now. Okay, it's not listening to me. Okay. Okay, so I'm going to do, instead of Rabbit, I'm going to say Kafka, and I'm going to start a container with Kafka being the container. And I'm going to start another container, again, with Kafka being the transport layer. And I'm going to start that. So now I have two containers running and the admin started. As you notice, and from the log, so the transport is mapped to Kafka. And the containers are actually joining, and admin knows that the containers are joining me. And going back to the UI, and then we load the containers tab, and those two containers are back up. With Kafka being used as a message bus to communicate between the modules. So I go to the shell, which for sanity's sake, we will do that. We'll see all the custom modules that exist and all the source adapters that exist. So let's quickly see how data partitioning works with Kafka. Okay, so I'll get back to that. So I'm creating a stream with the name HTTP test, And the definition for that stream, I'm giving, hey, HTTP, and listen to this port 998. And once the data is consumed, I would want to log it to using the log set. And I created that stream, but it's not undeployed, as you can see there. I did not give the optional deploy towards the end of that stream definition. The reason is I would want to dictate the stream to do something specific. We call it the deployment manifest, which is nothing but inline properties attribute. So I'm going to say, go deploy the stream named this, which I created before. And the properties for that stream is, to module log count 2. What that means is I'm expecting 2 counts of log module to be present. And I'm also saying this is the partitioning key expression that Mark Fisher was referring to. You can do interesting things. You can have spell expressions here, but I'm giving it the payload itself that being transmitted between the modules. So essentially, when the stream, this deployment happens, well, when we post data, what is happening behind the scene is there are 2 log modules that will be waiting to log data. Because of this partitioning key expression, once the data comes in the pipe from HTTP to Kafka bus, we do partitioning based on the payload hash code modulo 2. The 2 because it's based on the count of the actual sync. So if it's 3, it'll be based on modulo 3, and 4, then it'll be modulo 4. So that will determine where the data needs to be routed, partitioned, how it needs to be partitioned, and which container the data needs to land. So if you have like more, you're interested in some specific data, say customer ID, all the customer ID of some number needs to land in a specific container, so I can do all specific data computation on that. So that way, I don't incur an I/O hit. If the data is distributed into several containers, you are trying to merge all that, bring all that, and there's an I/O cost to it. So by doing this, you're landing all the data of similar kinds in one container. So you have that flexibility using the deployment manifest. You can dictate how the data needs to be written. So I deployed the stream. So as we saw there, I have 2 containers running. So I'm going to post this data just to show how. So I'm posting pretty straightforward data. I'm posting to this port, and the data being 1, 2, 3, 4. So I'm expecting the odd number being in one container and even number being in another container. It's nothing but payload, hash code, and modulo 2. So I'm posting that data, and I'm going to my containers. Let's see. So this is my container. It has the even number data being logged, and the other container, it has 1 and 3, that being the odd data. So that's being consumed, and it's being partitioned and routed to that respective container. So it's precisely how you can dictate how a stream partitioning can be done using Spring XD. And, you don't have to worry about writing code to do that. It's out of the box provided. And this expression can be a spell expression, Spring expression. So you have more flexibility to do some interesting things as you deploy the stream via manifest. So let me clean this up. One thing I missed to demonstrate so far is we've been talking about streams all along, but I forgot to demonstrate a job as an example. What is this out-the-box batch jobs that we have? So real quick, I'll touch on that. So we have Spark as a batch job that we expose. Let's try an example using that Spark module, job module. So I'm going to create a similar to stream as the developer fixture job create. The name of the job is Java word count example. And the definition for that job is use the Spark app job module, which is listed up. And the app jar, I'm using one of the sample jar files from Spark bundle. So I'm using Spark examples 1-to-1 Hadoop jar. And that's the jar, that's the location where it is at. And name of the app, my app. And I'm pointing to where the master is. So master is at this location. And the driver program, I'm pointing to the main class. This is inside the jar file. This is the package, and that's the Java the Java class name, Java word count. And the argument I'm giving is the data file. So I have a data file which has a bunch of words in them. I'm trying to do a word count using that job. So this is the test file that you see. There's some names in it. We're going to a simple word count using Spark job. I deployed that job. Let's make sure the negotiation between the cluster, Spark cluster, and Spring XD is successful. So let's verify that. So it's deploying. So while it's happening, I'll also want to point out the difference between Spark Streaming and Spark Job and Spring XD. So the main difference is the Spark Streaming, the driver program, as Mark was referring to, it actually runs in the same JVM process as our Spring XD containers where it runs. So that it's all collocated, and in the Spark Job, the actual driver program runs in a different process. We spawn a different process, and the driver program runs there. And it negotiates with the Spark cluster and to do all the native things, data computation using Spark cluster. And the data, once it is complete, the process tells Spring XD, hey, I'm complete, and this is the outcome. And we just have fixtures to show that. So now that the job is deployed, I can go to the UI to really make sure that the job is deployed. You can undeploy, destroy, and all that. And I go to this executions tab. This tab actually shows all the historical occurrences of events. And I had several times I ran this example. And the latest one is this, 217. So 753. So this being the latest example, and that is completed. So let's quickly see what happened to the word count example. So in the UI, I'm walking through all these buttons to see the actual job. And that's the Spark command, and that got executed. And this is the log. If I scroll down, and I see the word count being spit out. So this is handed back by the process to Spring XD, and we capture the log, and we persist it in our database, and that's why a database is a requirement for Spring Batch jobs. So that's precisely how jobs can be created, similar to streams. We just provide this out-of-the-box developer fixtures for you get up and running rapidly. Okay. Going back to the deck. So that comes to a conclusion of a few demonstrations that we wanted to share with you guys. So looking ahead, what do we plan to do? So the custom modules that you saw using Reactor and RxJava. So you saw the REST API that allows you to easily install the custom fragments and make it immediately available for use. So now we also have a plan to host the custom module bits in HDFS for more production readiness, and people prefer having it in HDFS, for example, and we are trying to enhance that experience. And we also have a data pipeline HTML5 canvas that we are developing that lets you actually create these streams that you actually saw that you interact with the shell. We have the UI is another endpoint that you can interact with. So that pipeline you would be able to visualize from the Streams tab and see and use a palette to drag and drop all these various adapters that you see. You'll have a palette that you can drag and drop to create a pipeline, and also a terminal-like text box inside the pipeline, so you can actually create a stream from there. So we are trying to enhance that experience, make it even more straightforward and simple. And along with that, UI will also have more metrics and monitoring capabilities that'll be part of the data pipeline UI. And we'll continue to evolve the out-of-the-box modules. These are all backed by Spring integration adapters, and we continue to evolve there. As we add more adapters, we'll put that into Spring XD and make it more straightforward. So you have a unified platform to consume various data endpoints and write to various data endpoints. The next flow that I have is Apache and Barry support. This is to unify Pivotal portfolio of products, and Spring XD will be gluing all our data products together and being having an Ambari plugin for the simplified, unified deployment and management experience of the cluster. And security enhancements we already have as part of our 1.1 GA release that we did last week. We already have basic authentication, we have LF integration, and we have file-based authentication as well. We're currently also working on granular ACOs, like access controls, like who has access to what stream, who can destroy them, who can create them. So we are trying to get into more multi-tenant clustering and be able to isolate applications from based on the roles and responsibilities. And the last bullet I have is the runtime, Spring XD runtime. It goes back to our portability theme. It will be available as a Pivotal Cloud Foundry service as a GA release in May 2015. With that, I will share these links. So our project is in GitHub, and we have our wiki that is as comprehensive documentation of all the details. You can see on the right pane, all these topics, especially around custom modules, all these creating thing, job, processor, and you can refer to any of these documentation. That'll be pretty straightforward. And we have a samples repo. All the demonstration that I did, it's in this project, it's in this GitHub repo. Like RxJava, Reactor, RxJava, Kafka Message Bus. So you should be, once you have Spring XD installed, you can just run any of these examples pretty straightforward, fairly quickly. Last thing I would want to share is our project, is in GitHub. We have it in all the features and issues. Our backlog is in Jira. So please, if you have any feature requests or you have some issues, please open up a new Jira story, and we'll be on standby and we'll take care of that and getting it part of our upcoming sprints and releases. With that, I'll stop and I'll hand it over to Peter.
Thanks, Sabby. Can you hear me okay?
Yep.
Oh, great. All right, excellent. So looks like Mark, if looks like the first question, or for Sabby, depending on who wants to get it, from Gerard is there any support for MapReduce jobs? Interesting. Who wants that one?
Yeah, I can answer. Yes, the batch jobs that are orchestrated through Spring XD make use of the different tasklets we have for running MapReduce jobs, Hive, and Pig as well. You can also use Spring Batch's native execution platform for doing batch jobs.
Awesome.
Yeah, and Sabby is showing a little example there. That's the obvious Hello World word example if you specify a mapper and a reducer inside your configuration file, and then you reference that as a step inside the batch job.
Yes, word count. Awesome.
The obsession over counting words never ends.
Yeah, right. I swear I remember seeing someone post a Samuel L. Jackson, say word count again one more time. Anyway, so I think that's it for questions for the moment. Folks, if you do have questions, now's a great time. Sabby, way to finish right at 11 o'clock. Nice job. And just to get people's juices flowing on questions, I know one question that came up in the last session that seems frequent is sort of to try to understand Spring XD in relation to something that somebody already understands, another piece of technology. So I was wondering if you could say a little bit about what Spring XD tends to get mistaken for and why. Storm, is it Flume, is it something else? Get that question a lot from people as they're trying to wrap their mind around what it is and isn't. Anyone want to take a stab at that one?
Yeah, so Spring XD, it's a pretty broad topic. There's several products that we overlap, so I don't want to get into details of each of the products. But on a high level, our goal is to simplify developer experience, make it more seamless, and so that you don't have to worry about several products in the Hadoop ecosystem and incur the debt on maintaining it, incur the pain points of maintaining them, or having to run the production costs and so on. So we are making sure it's straightforward. And if you need extensions, right? We are, in the path of embracing and extending as appropriate. So that's why we have strong story with Spark streaming. Although it's another stream processing framework like us, we see that it's complementary at the point that you can do some interesting things with these streams. You can do ML is using a Spark batch job. So we recognize that. So that's the reason why we make it more generic and more straightforward. So there are minimum. You don't have to write so much code. I mean, for example, if you're writing topology in STUM, you have to write your own code, extend interfaces, create all these different lines of code, and you bundle that, you deploy that as this Uber thing. So we try to simplify that. So we make sure you have a simple interface, you implement that. You do just worry about your business logic in it. And don't worry about, setting things up, infrastructure, or how do I run this? You get in that limbo. So we're trying to make that straightforward. And at the same time, we recognize what is a complementary product, and we make sure we tap into it and we give that. So enterprises and developers have what they need. So they have option to choose what's best for their use case. I guess that probably summarizes what I have in my mind right now.
Excellent. Thanks, Sabby. Yeah, it just seems like something we get pretty frequently. So, okay, great. Well, it looks like we've addressed all the questions. So I'm just going to kind of wrap up, and if one pops up at the last second, we'll handle it then. So just to make sure everyone's aware, we are certainly recording this webinar, and what I'm going to do is just put a link to where you can get a hold of the replay into the chat window, into the Q&A window, excuse me. So bear with me for a moment, and I'll just do that. Great. So you can get a hold of the recording. If you look in the chat, there's a shortcut to spring.io/blog. If you go there and subscribe to the Atom feed, that's probably the best way to get a notice that the replay is available. And then you can share it with your colleagues. Or, if there's something else you want to kind of go back and watch that was too quick, obviously you can do that. And if you subscribe to the blog, you'll also get a lot of other great blog content from our engineering group, as well as the notice about the replay. So recommend you do that. If for some reason you just want the video, you can go to spring.io/video. That's a shortcut to our YouTube, and subscribe to our YouTube channel there. So with that, I think please come back and join us on February 24th. That's a Tuesday. So next Tuesday, Josh Long is going to be introducing Spring Session. Pretty cool new project for kind of taking a new look in the cloud, in the area of the cloud at HTTP session, and reimagining how session state is handled a little bit in applications. So I think that's it for the moment. Oh, I should just mention very quickly that you can get a hold of the software. So if you just go to the Spring.io project page, which Sabby's very kindly pulled up for me right there, you just click on the Quick Start button, and you'll get some download links. You can grab it via Homebrew if you're a Mac kind of person. There's also a Yum repository, and then you can just download straight binary zip if that's your preferred. Also, you can get it from Maven as well. So a lot of ways to get the software. The important point is that you take it for a test drive and try it out and give us some feedback. We'd be very grateful for thoughts, comments, questions, constructive criticism, et cetera, et cetera. So looking forward to seeing how people are going to start using this out in the wild. And I think with that, Sabby, is there anything else you or maybe Mark want to say just before we call it a day? And thanks for doing such a good job, answering the questions.
I think you pretty much covered everything, Peter. Yeah, the only other thing I would add on to or rather reiterate is the fact that please try it out. And if you have any new feature requests, interesting things that you want to do with Spring XD, please let us know. I mean, you just open a Jira story, and we'd be happy to and prioritize that, and then see how we can help you out. Should we?
Yep. All right. Thanks, everyone. Hopefully see you next Tuesday. Have a great day. Thanks for your time and your attention and your questions. Bye-bye.